Now let's turn to search. Search is really just a walk that stops early. We walk the list looking for a value, and we stop the moment we find it. This is search in C. It is a traversal that stops early on a match. We walk from head with a cursor cur, while cur is not null. Moving with cur becomes cur arrow next. At each node we ask, does cur arrow data equal the key? If yes, we return cur the address of that node. If we fall off the end, we return null, meaning the key is not here. Let's look at the cost. In the best case, the match is right at the head, so it is big O of 1. In the worst case, and on average, it is big O of n, a full walk when the key is last or missing. A list has no order to exploit. Unlike a sorted array, it cannot do binary search because there is no big O of 1 way to jump to the middle. This is the key idea. Because this search returns a pointer, not found is null. But an index returning search, like binary search in Chapter 2, returns -1 instead, a documented sentinel that is not null. So match the not found signal to the return type. A pointer uses null, an index uses -1.